will present you text normalization with Invisible XML Roundtripping. I'm Alain Couthures from agenceXML. So, first of all, let's consider that text normalization is quite important for text processing because it allows to reduce the text size, then the storage in databases. It's nice also for enabling string comparisons, and then it's also useful for classification. Let's consider that normalization is quite different than canonicalization, because canonicalization is about a standard defined for text values, not necessarily the shortest one. Invisible XML is a technique for parsing text values and obtain an XML document as a result. It's a declarative approach with rules and symbols, with indicators for marks for generating attributes, for removing text from the input, or for insert extra text with the regular expression, and so on. Roundtripping Invisible XML is the opposite, which means that from an XML document we want to generate the corresponding text values which would be necessary to generate this XML document back. Roundtripping is quite important with Invisible XML because usually there are contexts where text values have to be edited, and we might use XProc, XForms, any language for that, and we want to generate it back after editing. Let's have in mind that there are many possible similar text value which might generate a shorter one, let's say normalized value, and also what's interesting for about roundtripping is that it might reveal unexpected text values which are valid for this grammar, but that the author might ignore. So let me introduce you the Grammix implementation. It's a JavaScript implementation. It's based on an Earley parser. Itself based from a nearly package, the nearly package, which is quite famous in the JavaScript community. It will expand the BNF-like structures into extra rules, because an Earley parser doesn't natively process them. It will then store this expanded grammar into an array, and this array will then be used within a function or a module, a JavaScript function or module for this grammar, and then it can be used then to parse the input values. Actually, for Grammix, the grammar will be enough to support also roundtripping, so it means that you don't have to add extra instructions of any kind. Just the grammar is enough to generate from the XML document the text input as it would be in the normalized form. Of course, there are constraints for round-tripping because if you consider a grammar, usually you will see that there are, for readability, meaningless characters, spaces, new lines, and so on. Let's say also separators, and so. Well, it's to be considered, and for as I said before, many inputs could produce the same XML output, so one has to be chosen for round-tripping, and the normalized inputs, the result from round-tripping, should be the shortest ones. So first of all, Grammix will normalize the grammar. The normalized grammar will be the one which will only accept normalized inputs for a given grammar. Normalizing grammar is quite an extensive procedure based on recursive processing. With some examples, you can see that when a string has to be removed from the input text, when it should appear maybe just zero occurrence or many, we shall remove it for the normalized grammar. It's the same if it might appear as an option. Whether when it might appear at least once, we should keep just one instance of it. With a regular expression, I would say, with an alternative, it's A, or C, it's B, to be removed. Just keep the first one, A in this example. And as a more complex example, if we consider a repeat one, an alternative between a string to be removed and another one, the B string, to be kept. Let's distribute the repeat one, and then it means that we'll just keep one instance of the removed string A and let the repeat one for the B string. Then, based on the normalized grammar, round-tripping will be possible when the normalized grammar is inverted to generate the text back. So when a string had to be removed, it will be inserted instead. For treating the XML elements, it's necessary in this inverted grammar to consider new symbols, new types of symbols. There are start and end tags to be around the symbol, so the role for the symbol will not be altered, but just in the role calling it, there will be the start and end tags. For attributes, it's quite different because they might appear anywhere between the start and the end tags. So they are processed on the fly, which means that the rule where there is a an attribute to C. In this example, it will be replaced, the symbol will be replaced with this new symbol for treat the attribute in the XML document. There are still ambiguities to consider because depends on grammars. In this example, you have an A rule for a string where zeros or one are at the beginning or at the end of the item, and if it's repeated let's say five times, inverting the grammar will generate 32 normalized values. It's not possible to distinguish which one is to be kept, maybe just the first one, but it will be a problem for memory and time performance. Typically, it will occur in processing programming sources, where usually strings can be defined with apostrophes or quotes. There are workarounds for this problematic. For example, it's possible to add extra attributes within the grammar, so they are generated in the XML document, then back the roundtripping will regenerate the which alternative was first used when parsing the input the first time. So okay, but the grammar has to be modified, and the XML document has extra notes. Another possibility is to consider pragmas, which are not already supported in Invisible XML, but it's a good way to state that this alternative has to be considered when roundtripping, and the other one are not to be considered. So, with all the Grammix possibilities, I will say as a conclusion that a grammar, of course, is nice for validation. It can parse the input document into an XML document, so it's very useful, of course, but it can also be used to normalize the input value. Then I will ask whether XPath should consider how to process Invisible XML. Currently for XPath 4.0 there's just one function which is defined with an argument for the grammar, the string, or eventually an element, and options, but returning just a function, accepting a string as a parameter and returning the XML document. Okay, so let's consider now a Grammix demo. Okay, so this is an HTML page with three text areas, one for the grammar, one for the text, input text, and one for the resulting XML. We will choose a sample, let's say dates. So you can already see that Grammix is complaining about the input text, which should not be empty because it's not this way in this grammar. It's not a valid value. So let's enter value. So you can say that it's valid and the XML document is generated. We will modify it directly within the XML document. Then, as you can see, the normalized value has been generated for this date. Because this grammar allows to enter multiple dates, we will add another one. So the XML document has been updated. We will modify it again. Oops, as you can see, the generated input, the two dates are not separated with a space character. Let's see why. It's just because of the rules in the grammar, because it says that a date might be ended with a space character, but it's not required. It's still possible to just iterate it and start after the year with the next day. So we'll modify it with, for example, something like this. So now the text is not accepted. We had a character. If we had two spaces, now we can see that it's ambiguous. Why? Because the S symbol in the first row is ambiguous with the S symbol in the second row. So we might delete this and so on. Now it works. Oops. Okay. Let's have a look at what happens to the XML grammar. As you know, it is itself expressed as in XML formats. So you have the XML document for the XML grammar. If we just not really modify it, but just add a space within between elements, we'll see that the input text has been modified accordingly. So what we can see is that the colon has been replaced with the equals sign. There is no more spaces between symbols. Just a single space is enough for separating rules. And when there is a comment, it's not even required to have any space. So it means that if we would like to get the semicolon, the colon back, we should modify the rules within the grammar. Okay, but maybe we will show instead, I will show you instead a demo of Grammix from Node.js. Okay. So, first of all, we will ask Grammix to consider the XML source file and to generate a module from it. Then we will use this module interactively. So we need the constant for that. We will import the module. This.mjs. Forgot quotes. That's it. Then we will run it and render as a text in the console. Okay, and back to the XML document, to the text value, sorry. Let's copy paste this document. Okay, so back to the presentation. So now, as a conclusion of the conclusion, I will explain you what I consider for processing text in XML nodes. What could be useful. So first, a question is about how to integrate XML grammars within schemas, and how to do that for XForms bindings. We should consider that invisible XML grammars are useful to let's say generate types. Yeah, we need such integration in XML technologies. Namespace support is also useful because when you generate an XML document, if it should be conformed to a schema, it's nice to generate according namespaces nodes. Grammix already supports namespaces in its own way with XML namespace nodes added at role level before the colon, before symbols, and well, it can also treat prefixes and so on. Another idea is about how to manage within XML programming languages Invisible XML. Instead of a function, we might consider that XML could be seen as a new XPath value, XPath axis, sorry, which means that if you have, for example, an attribute which is conformant to an XML grammar, you should be allowed to use this new XPath axis to directly access the corresponding document element for this this text value, and again travel the tree, for example, to an attribute or any sub-element. This could be quite interesting for selecting values, nodes, and so on, but also interesting when modifying, if there is an XForms bind for input controls to such a generated node. The initial text node as the length in this example would be automatically updated. Okay, this is the end of this presentation. Thank you for your attention. So, if you have questions.
Are there any questions in the chat? There is a question by Mohammed. Will you do it in French or in English?
In I don't know. Hello, Alain.
Hello.
Very interesting use of XML. I think it gives us so many ideas on how to use it and where to use it. I have only one question, is about this ambiguity attribute you put. It's an instance level detection of the ambiguity, if I am correct. And I think that this word is even misleading, because I think what you just need for some of the work is to detect if your transformation is injective in the mathematical sense, because then you can round trip from the injective version back to itself. And maybe that's enough in most of the use cases. Just that. Did you get my point? I don't see you on the screen.
Sorry, what is exactly your question?
My question is this ambiguity attribute, I think, is itself ambiguous. I think what we need is a distinction of what we call ambiguity. One is if you really want to round trip back to the original. The second is if you want to round trip on itself alone.
That's why I was talking about pragmas. It's a way to say that with the two alternatives, the second one, for example, is the one to consider when round tripping.
Thank you very much, Alain Couthures.